Solve each rational inequality, graph the solution set on a real number line, and express each solution set in interval notation. Looking at this problem, I have x plus 5 divided by x minus 2 greater than or equal to 0. This time we have a fraction. So to find our critical numbers, we must take the numerator, set it equal to 0, and the denominator and set it equal to 0 to find our critical numbers. So let's subtract 5 from both sides. We get x equals negative 5. Add 2 to both sides. We get x equals to positive 2. So there's our two critical numbers. We will use those numbers to separate our number line into intervals. There's negative 5, here's 2. So I will use those numbers to separate my number line into 3 different intervals. I have everything less than negative 5. I have numbers in between negative 5 and 2, and then I have numbers greater than 2. Look at my original problem, greater than or equal to 0. So I am looking for positive intervals. Anything greater than 0 would need to be positive intervals. So these are my critical numbers. Let's pick some test numbers. A number to test that's less than negative 5, I'm going to use negative 6. A number in between negative 5 and 2, I'm going to use 0. A number greater than 2, I'm going to use 3. So we're going to pick these test numbers to plug into x plus 5 and x minus 2. Bringing the numerator and the denominator over here, those are the binomials that we'll be substituting our test numbers into. Plugging in negative 6. Negative 6 plus 5 gives me negative 1, so I will place a negative. Negative 6 minus 2, that's negative 8. I will also place another negative. Now, in the original problem, these are being divided. Remember, your division and your multiplication rules of negatives and positives are the same. So a negative divided by a negative would give me a positive. You could also multiply those. You would still get a positive. Now, I'm looking for positive intervals. Therefore, this is an answer. We will shade everything less than negative 5. So if negative 6 works, then every number in this interval works. All right, let's plug in 0. What's 0 plus 5? Positive. What's 0 minus 2? Negative. If you divide positive divided by negative, you get a negative. We don't want negative. So therefore, I'm going to cross out that interval. Testing positive 3. 3 plus 5 is positive 8. 3 minus 2 is positive 1. A positive times a positive gives me a positive. I could also divide those. Positive divided by a positive is still a positive. We do want positive intervals, therefore I will shade everything greater than 2. So now my answer, let me draw my final answer, would be from negative 5, and I would use a bracket at negative 5, shade everything to the left. And at 2, let's talk about if we need to put a parentheses or a bracket. Even though the original problem has an equal to, you can never include a number that causes the denominator of the original problem to become 0. Well, if you plug in 2 into this original problem, 2 minus 2 gives you 0. Therefore, 2 cannot be included in the final answer, because it gives me 0 in the denominator. So instead of putting a bracket at 2, I will use a parentheses at 2 and shade everything to the right. So 2 is not included. You can never include a number that causes the denominator to become 0. So if I was to write my answer in interval notation, to represent this interval or this region here, I have negative infinity to negative 5 with a bracket, union to represent this region, 2 with parentheses to positive infinity. So that would be my final answer in interval notation. Here's my answer in interval notation. From negative infinity to negative 5 with a bracket, positive 2 to positive infinity with parentheses. Even though the original problem had an equal to sign in it, we cannot put a bracket at 2 because 2 is in the denominator. If 2 plugged into the denominator, minus 2 would give you 0. And you can never include a number that causes the denominator to become 0. So here's your graph of the final answer, and here's interval notation of the final answer.